So today my talk will be on how to start when the server goes down. So just a poll here. How many of you here use Heroku or AWS? How many of you went down last month when it went down? Oh, there's someone behind. Okay. So basically this talk, right? Go away. So basically this talk will be just some basic stuff that you need to do to make sure that you don't go down when AWS decides to go down. So yeah, why do you need to care? So first thing when you go down is this: your customers don't care why you're down. Your customers only know that you are down and your service sucks. Second thing is that you lose sales as a result of going down. Your customers will go to your rival company, and as a result you get bad reputation. You're the company that keeps going down, not Amazon which keeps going down. So what this talk is not about, it is not a step-by-step magical formula to get you 100% uptime. There is no way of ensuring that. You can only minimize your chances of going down. And yeah, you basically have to find the right balance between the cost and how much you want to stay up. So that said, there are very cheap sources of backup servers, services like Red They offer you $5 a month for a basic thing to store your data in case of emergency. So yeah, what this talk really is, right, is actually introduction to distributed systems. So I reckon that if I had put introduction to distributed systems, no one would have voted for this talk. So I have to put something more sensational. So what is distributed systems? Anyone here knows what distributed systems are? No one? Okay, so distributed systems, according to Turnbull, who's a very famous computer scientist, is basically a collection of independent computers that appear to users as a single computer. So Google is a distributed system, Facebook is a distributed system. And most of the core ideas I got for this PowerPoint is from this book, which is actually very awesome. Yeah. And yes, it's one of those here stuff that I reckon wouldn't get voted out of this conference. So yeah, you have to think the title of it. And yeah, it requires both practical ability and theoretical knowledge. So yeah, in this talk we'll just be dabbling in the surface of things. So yeah, the main design goals of distributed systems is actually quite simple and quite commonsensical. First one is being fault tolerant. First one is being fault tolerant. Second one is to be transparent. And thirdly, you need to be scalable. Fourth, open, and fifth, secure. So basically, you have to meet these 5 design goals when you build a distributed system. And the first thing, so what fault tolerance is basically when one part of your system goes down, your system doesn't panic and go down with it. It will stay up, and your users do not know that you are down. And that's also known as making resources available to people all the time. And the next thing is transparency. So for a system to be transparent, right, you have to have the same response to your users no matter where they're accessing it from. And the other thing about transparency is, okay, so how in computer science you have this thing called Big Indian and Little Indian with an E-N-D-I-A-M, not the I one. So yeah, so there is different ways for the computer to store data. So when you're using a small Indian architecture and a big Indian architecture, it will return you different stuff. So what you have to do with distributed systems is you have to have a middleware layer to actually abstract out the details running in the back end, so that when it goes to the front, the user sees the same thing no matter where they are. The third thing about distributed systems is that you have to be scalable. You have to be easily adaptable to increased load, which is basically what all these cloud services that you guys are using these days claim to be able to do. And you have to be open. You have to make it very easy to extend and re-implement certain parts of the system, so that it's basically you just bunch a whole bunch of modules together and plug and play. And there's normally a set of rules to define the standard behavior between all these different modules. If I remember correctly, it's called the interface description language. And lastly, which is overlooked many times, is security. You have to have network security when your different servers are communicating with one another. They should be encrypted, that kind of stuff. Users should be authenticated before they are allowed to access data. And there should be access control to see who can access what data. So, the boring CS stuff over. for your web app, so what you need to do for your web app to be fully distributed. So I'll just run through a few of the key concepts, and there are some of the services you can actually use to do all this stuff. So first is replication. So just to check, okay, so who here runs production systems? No one? Come on guys, there are many professionals here. Okay, no. So who here, when you run production systems, you have replication? Okay, I see a few hands here and there, okay, good. So replication is basically, yeah, this is a Wikipedia definition. It involves sharing information to ensure consistency between redundant resources of the software or hardware components to improve reliability, fault tolerance, or accessibility. In human terms, you store your data multiple times in multiple locations and pray hard they don't die at the same time. That is the most human version I can come up with. So yeah. So just a brief introduction of what replication looks like. So you have a database cluster, you have 4 servers here. And generally what you have is that you have a master server, you have 3 slave servers. And when your master server goes down, what happens? So it goes down. At the point where it goes down, the 3 of them will figure out that that guy is down, and they'll have a vote within themselves. And after they're voting, another guy will become the master. Basically, and then this called automatic pour over. So a new guy will be appointed master when it goes down. So the main gist of the idea on replication, right, is that you can do reading on any of the nodes. So any of the slave, master, slave you can use for reading. But you write only on the master node to ensure data consistency. And it works on the principle of eventually correct data. So yeah, here's an example. So assuming I have this configuration right now. So my web app writes a piece of information to the master node. Now the slave node does not have this data as of now. So what happens is that you'll transfer it over eventually. So when my user accesses the web app, you'll still be reading the old data. But probably after like 10 seconds to 20 seconds, you'll transfer over and everything is fine. So yeah, eventually correct data. And yeah, the next idea that is important for building web apps that have distributed, that are based on distributed systems is sharding. So here again is the long definition. I forgot where I took this from, but yeah, it's basically cutting your database into a lot of different parts and then storing each one in a different physical location. So in sharding, right now of all the databases out there, one of the few that actually does it for you natively is MongoDB. So what it does, in a more humanly understandable version of this, is that it stores data in logical chunks based on a predefined shard key. So you define a shard key as in how do you want to shard your data, and then it will cut your data into pieces and keep it in separate locations. So easier way to understand is this. So let's say I have this table. It stores users in America. And the shard key that I'm using in this case is the state that the user is in. So for users from Alabama to Arizona, I'll store in machine 1. From users in Nebraska to New Jersey, I'll store in machine 2. So this way, when one of them becomes more than 64 megabytes, I'll split the chunk into 2 and separate them into different chunks and then move them around here. That's basically sharding. Anyone has any questions so far? No? Okay, good. So what has this got to do with staying up? Now imagine you have this problem, machine 3 goes down. So part of our users can actually still use your system despite a part of it being down. And when those users in machine 3 complain that our service is down, your users in machine 1 and machine 2 say, no, it's fine. And yeah, they'll think that's the other problem. So yeah, it's good. You know, you get users to fight your case for you. Yeah. So now merging the two, how do you merge the two together? So assuming you merge the two together, you have both replication and then you have sharding. So in this case, it's even more fun. When machine 3 goes down, it doesn't really matter now. Because your machine 6 is up, and your machine 6 will continue to bring all this data. So it's basically writing this middle layer in your web apps to ensure that data is actually synced and there's redirection. You call to different servers when the servers go down and stuff like that. So next up, I'll just do a small case study on how some of these companies actually do it. So have you guys heard of Netflix? Okay. So Netflix is this very macho company that likes to inflict pain on itself. Yeah, they do this thing called self-inflicted. So anyone knows what is this? Or rather who this guy is?
Chaos Monkey.
Yes, the Chaos Monkey. So Netflix is a Simian army to shut down their servers for fun and to spot weaknesses in their own system. They have all these different monkeys and gorillas. They really call it this stuff. So one of the coolest thing that they did, right, was the Chaos Monkey. Now, I actually installed this on a former client. He was very angry. And I was like, dude, I'm only telling you the flaws with your system. Yeah. So it shuts down instances randomly for fun, and then it gets a team to actually think of building auto recovery system so that when you shut down, auto recover. Shut down, auto recover. That way, you almost never go down. Latency monkey is another interesting concept. So it introduces artificial delays in client-server communication. So because most of Netflix architecture, right, they actually use a middleware to communicate. So the latency monkey will actually go and play pranks with the middleware layer and increases the latency like crazy. And it's useful for testing the fault tolerance of new services. So assuming you have a new services that go online, it requires an API from a server to actually figure out what to do. So in this case, it's simulating the downtime of the API and ensuring that a new service will actually stay up in case of downtime. Yeah. And there's another guy called the conformity monkey. Basically what it does is to shut down servers that don't adhere to best practices and forces the service owners to relaunch them properly. Dr. Monkey is another guy who just runs around checking on the health of the monkeys, and he removes the unhealthy servers from the cluster. And Security Monkey scans for security violations and vulnerabilities, ensures all the certs are working. And last one, my favorite. So last month, the whole Amazon availability zone went down. First time in history. So they added this new guy called Chaos Gorilla, which will shut down all their servers in the availability zone. Now imagine if you go back and do that in your own company. Your boss will kill you. So yeah, what can you do? So first thing, you can run your own Siemens army. They have actually released the code online. You can go download it, compile it, run it on your own system. They're actually nice enough to do that. But that said, you're in Singapore, most of the bosses wouldn't allow you to do that. So next up, I've used Windows Azure, they're pretty good. They actually do geo-replicated data storage. So what happens is that when you send a piece of data into the Azure cloud, it will get sent to 2 different data centers across the world. So when one data center goes down, your data is still alive. And I think that's a pretty cool feature that AWS doesn't have. And the price is the same. And they have built high availability features, so you can basically add servers, and you can add extra servers to say that these new servers are part of this availability set, so that when one of them goes down, the rest will take over this one that went down. And they have a tech support hotline that doesn't require to pay $600 a month for. Yeah. Another thing that I personally use to ensure high availability, to ensure my services stay up, is MongoDB. So MongoDB, this is a production architecture of MongoDB. So you have a client app and you have the Mongo S processor. So Mongo S is basically the processors that will decide which shard it should go to. And then there's the configuration server that stores, like, let's say this shard key belongs in this replica set, this shard key belongs in this replica set. So the Mongo server, the Mongo S servers will create a config server for where your stuff is and direct it to the right guy. And in each shard, right, is basically what you saw just now, the data that's cut by the shard key, and each one of them is a replica set. So with this, right, any one of the MongoDB goes down, you're still alive, and you are still pretty much online. So for MongoDB, it's actually quite easy to set up. All you just need to do is to type in this, fork it to run in the background. REPL set is replica set. You put a replica set in there, and you put a log path, and you are basically you have a replica set running. And when you go into Mongo, you just type this command and you are done. So I'll just do a short demo of me bringing one of my servers down and bringing it back up. So this is currently my server running on Azure. So I do rs.status. So right now, as you can see, MongoDB2 is the primary, is the master, and MongoDB1 is the slave. So when I do a, okay, so this is the master, this window here, and this is the slave. So, exception. Okay, so I just shut down the server, and on this side, yeah, it instantly detects that a guy up there isn't healthy, it's not reachable. So after a while, it will keep on trying to ping the guy until a timeout happens, which is 20 seconds later. So yeah, I have to wait for a while. Okay, it's not responding. Weirdly. Okay, it's not supposed to do that. But yeah, you can go back try. I think one of the problems I'm having now is I don't configure the endpoint copy of Azure. I suspect that is the problem. So yeah, let's go back and start it back up. Yeah, the endpoint I didn't configure properly. So yeah, what should happen is that it should become primary under 20 seconds. And then when I start it back up, the state should be primary again. It should be back to normal. Yeah. That was a bug. Azure side, you have to set endpoints everything properly. I didn't do that. Yeah. So yeah, stuff I'm running on HA. So I actually run a HA cluster which I rent it out to clients for a fee. And yeah, I built this app to sync my Instagram photos with Dropbox. I run it on HA cluster, GeekcampSG. Well, it has a rather unfortunate thing actually. Last month, both my servers across the world, in 2 different sides of the world, went down at the same time. So that one can buy 40 AD. Yeah. So yeah, I've pretty much reached the end of my talk. If any of you have any questions on HA distributed systems. Yeah.
How do you do the replication or the failover manually in your code?
So for MongoDB, right, you can, in your application code, you can put all the different servers in, so you'll try one by one. So when one isn't there, you go to the next one and try. When the next one isn't there, you go to the next one.
So what does that have to do with MongoDB?
No, so MongoDB by itself, right, will automatically fall over to the next server. So you'll elect a new master server.
So it's nothing to do with your own code, just the config.
It's an easy way for people to roll out HA code fast.
It's a config thing in the MongoDB.
Correct. But then on your side, you can have this thing to access your API to change your DNS immediately when your one server goes out. If you're on Cloudflare, it happens instantaneously because there's no DNS caching on Cloudflare side. Yeah.
So what happens when the database comes out? The synchronization will happen by itself?
It will happen by itself automatically. Yeah. Yeah. It works on 32-bit, but it sucks. So please use 64-bit. I haven't seen a real server environment in 32-bit before as well. So I mean, I can't fault them for not implementing it properly on 32-bit because no one uses 32-bit in production environments anyway. No, I mean I just run 64-bit. Yeah. Anyone have any more questions? No? Okay then, I guess I'm done. Enjoy the rest of the day. At the end of Geek Camp, there's awesome after party downstairs. Free booze. Yeah.